So, minimal functional programming concepts in JavaScript. I'm your host for this talk. I'm Mohammad Hassan Ayaz. I love JavaScript and I'm going to introduce myself towards the end of the talk. But just so you know, I have 7 years of experience with JavaScript and that's quite a lot. So, having said that, let's jump into what the functional. So, what are we talking about today? Why are we here? So, you might have worked with JavaScript for a lot of time till now, and you might have used functions already, but why are we talking about functions and what is functional programming in general? So, let's talk about some styles of working with JavaScript. So one of the styles that we have with JavaScript is called imperative style. And the way imperative style works is basically we have a function which is called greet. It basically returns a string which is prefix plus whatever variable is passed. So it basically accepts a string parameter, and once it gets it, it then returns it prefixed with this prefix. Now, the fun part is that this prefix is not part of the function. It's an external variable which is outside of the scope. So this particular function depends on an external variable, and so if anyone manages to change the value of this prefix, this function will start behaving differently. So for now, if I just do hello and if I pass this string sn, what we get out is hello sn. And if I try to change this prefix, or anyone in my team changes this to, let's say, hola or hey, whatever, this string will then change and this function will no longer work correctly. So this is the imperative style of working that we do today. And this is then prone to bugs because at one moment it was supposed to say hello SN, but now if anyone changed that, the whole situation changed now, and even if you had tests for this, they would start failing because now everything has changed. So how do we try to fix this? How do we change the style of how we work? So the other kind of style that we have is called functional style. So in the functional style, we have functions for everything that we do. So instead of having an external dependency, what we could do is that we could have a function greet, which already had that prefix within the function, and then it would just return a concatenated string. Now, what does this mean and how does this solve our problem? So for every given input, the amazing thing that we have right now is that it will always return the same output. So whenever I provide SN, exclamation mark, it will always provide me back the hello SN. And this is configurable, but still now it is less prone to errors. So this function doesn't depend on any external dependency at the moment. And that's how we rule. Now, we'll talk about pure and impure functions, because when we are working with functional programming, we do want to make sure that we are writing as much pure functions as possible, and we are going to see what are the pure functions. So if we have a pure function, we should have everything set up in a way that we have an input x, and a function will be called pure if for a given input it always produces the same output. So if we have input x, it will always produce the output y. If we change the input to, let's say, m or n, there will be a different output, but for x, the output will always be y. So that's how you construct a pure function. So a pure function greet will always return hello sn if I'm providing this particular input to this function, and that's why it's called pure function. If you talk about an impure function, this is an example that you see on your screen. So this calculate price is a function which basically takes a base price, which is this parameter, and then it basically returns math.random with the base price. Now you can see that we are now console logging the value with 27. So this input is 27 and we are providing it 2 times. So it's the same input that we are providing. But the thing is that this input even being the same, produces different kind of output every time. So you can see that once we have 27.30 and the second time we got 27.86, and you can basically test this in your own browser or the Chrome DevTools as well. And the reason is obviously because of the math.random addition to the base price. Now consider another example. We have a function which is called user exists, but essentially we have a user. So what we want to do is that we want to find out if my user exists in the users array. And this is something that happens a lot of time when you're working with selecting managers or let's say owners for a particular entity. You have to find if it is already in the selected array or not. So this is kind of the same scenario. So we have a user with the ID 2 and the name Scott, and then we are trying to find if the user exists in the user array. And in the users exist function, what we are doing here is that we are looping over, or we are trying to run the find method on users array. But this users array is not part of the current function, which means this is now an external dependency. So if the users array changes, the output of this function will start to change, and that makes it an impure function because it is dependent on an external dependency. Now if we talk about this further, what would happen is that we have, let's say, an array, and this is another example. So if we have an array of users, for instance we have these 3 users, or you could call them students, and we have a function called users count. So this users count basically loops over the users array, which is an external dependency. So we are 100% sure, okay, this is not a pure function because it's depending on an external resource. But another problem that we have with impure functions is that they should not modify any external variable. So they should not be mutating any additional or any external variables, which we are actually doing here right now. So we are doing users.filter, and then we are assigning the result to the users variable. So we are modifying this external user variable here in our code. This is not a local variable or the variable which exists in the scope of this function. This is an external variable. And then we are returning the user's length, which is fine, which is what we actually want to do, but it is modifying the external resource, and this is absolutely not what we want to do. So one of the things that you could do while working with a functional paradigm in JavaScript is you can use higher order functions, and you might already know about that, or you might be actually using that within your code every now and then, but it's good to know why we use them. So how would using this higher order function solve my problem for coding? How would it help me? So let's consider this example. We have a function named percentify, which takes a parameter named %, and then it basically returns another function. So you can see that it is returning a function which accepts a value, and then it returns back the value divided by 100 multiplied by the %, whatever we have. So why do we want to use this, and how would it kind of work as in a pure function environment? So for this, we are going to see a simple example. So I'm going to go here, and now we have this percentify method here. So what I want to do is that I should be able to have a function on which I'll provide a total value, and then I should get back a percentage of the number that I'm providing. So for that, I'm going to create a percentifier, or let's say I could say const, and I could say 10%, and I can simply go here and say percentify, and here I'm going to provide the value 10. So I'm talking about 10%. So this is a function which I can call later on, and this is basically this return function. So what I'm going to do here is that I'm going to do console.log 10% of whatever value we want. So let's say 1, 2, 4, 5. So let's say this is a value that we want the 10% out of. So if I run this, you can see that we are getting 124.5. So it has now taken a 10% of it. Now how is this pure? The way it is pure right now is that no matter how many times you call this variable, the result will always be the same. And the fun fact is that this particular function, which we are calling with the value 1245, comes here, and then it is calculated, and then it is being multiplied by a variable which is not inside this function. So this % is an external variable, but even that external variable is encapsulated within this function, or a higher order function, which means that now we have encapsulated this %, and no matter what happens, this will never fail as an impure function, because this is not an impure function now. It will always return back the exact value given the exact function. And this is just some theory that you need to understand. You might be using that already in your daily routine. So I can actually create a lot of percentifiers with the different values. For instance, I could say 25%, and I could say TF%, and then if I use, let's say, 25% here, you can see that we get a different value. Now this 311.25 is actually 25% of 1245. So I can create different higher order functions, or I can create different functions using higher order functions, and still be able to test them correctly, and still be able to work in a functional paradigm. Now, moving forward, the next thing I would recommend is using MapReduce and filters, etc. So we have these functions coming out of the box from the JavaScript API, and then we are also able to use the loops. So instead of using for loops in the older manner how we used to do, we can use these functions. So we are using the functional paradigm, and I'll show you some examples on how we can do that. Let's consider this example. So we have an animals array. I'm not showing what that array looks like here, but we have an animals array which has a name and the species of the animal. And what we want to do is that we want to take out all of the cats from those animals array and put them into the cats array. So what we are doing here is that we are looping over the animals array, and then we check if the current element in the iteration is a cat, then we push that particular element into the cats array. It can be shortened down to this statement. So you can see that we are now doing animals.filter, since we are using filter, and then we are checking if the animal species is a cat. And you can see that the code that we have written is significantly smaller. That's the first thing. We are not creating any additional variables that we were creating before with the I and the len. We don't need them now. And it's not just the magic of syntax, it's actually that we are writing lesser code, which means that when you will ship this code to production, the bundle size of your application will be a lot smaller. So this is just one function, but consider you have tons and tons of modules that you are shipping. This would ultimately result in a lesser bundle size. So highly recommended to use MapReduce and filter. If we go forward with this approach, we can change what we had here, which means this condition, and then we can move this to its own function called isCat. Now the benefit of this will be that we can actually put a test or a unit test around the isCat method, and now our code is testable. And then we are using the isCat inside our filter, which is almost the same what we had before, but now it's a function which is doing something. And this is actually the right way to do. So now you can see that the code is much cleaner, and also you're able to test your code in a better manner. The next thing I would like to highlight is we have to avoid mutation. We don't have to modify the actual objects because that results in a lot of errors. And I'm going to show you an example which is pretty much very common in junior developers, or even sometimes senior developers also do it. I've done it many times, but this is something really common among teams. So consider this situation. We have an array of students, and then also we have this function in which what we are trying to do is that we have to get another array in which we have a different reduced age for every student. So by default, this age is 29, but what I want to do is that I want to have an array in which every student is 4 years younger for some reason. And this is something that you might do with some different kind of data, but might be able to do. So what happens in this case is that we are mutating the actual student object here, which will result in an issue, and this is a problem. So let's quickly see an example here. And then we'd also see an example of the map filter. I think we have not gone there. But let's see this example. So we have students, we have 3 students here, and then we are talking about students age reduced. Now, if I run this, you can see that all the ages are reduced. So we had 29, 25, 25. Now we have 25, 21, 21. So every student's age is now reduced to 4. That's how easy to reduce age, if you ask me. Now, if I go ahead and copy this, and then if I paste this, and now if I try to just log down the original array, what would happen? You can see that the original array also now has this 25, 21, 21 instead of the original values. Now we have actually modified the original array, and we cannot go back to the original state, and we are gone. So how do we avoid this? So first of all, we have to avoid mutation. And if I talk about how we can achieve a better way of doing this, is to basically return a new object in which we would have the updated property. So you can see that here we have the original student object. So we are kind of spreading it out. We are returning a new object, so it is not modifying the original one. And in the new object, we have the property in which we are changing the value of the property. So we are not modifying the original object. And this is the right way to do. And I'm going to prove that to you. So if I go here, and then let's actually copy the code from here. Control C, Control V for the win. And here we are just going to replace this. And if I run this now, you can see that now we have the original values of 29, 25, 25, which were the original values. So that's how you try not to be boiled by the mistakes that might happen if you are changing the original objects, or getting in those situations. As we were talking about the MapReduce scenario, going back to the MapReduce scenario, instead of using this for loop, what we could do instead is use the MapReduce methods. And one way of doing that would be if I just go and comment this out. And what I would do is that I would create a couple of, I can simply say const cats equals, and then I can say animals dot filter, and then I can provide this condition here. So I'm going to say animal, and then let's just quickly write this, and then this one. So now if I log here, you can see this is not animals, it's animal. So if I right now see, you can see that we have 2 cats. So one is white and second is Leslie. So we have 2 cats here now, and one is turtle and one is dog. Now if we go forward, we talked about creating a function. So we can say const is cat, and then what we would do is we would basically have this condition. So I can simply copy this from here, paste it here, and we are going to provide an animal. Now I can use this isCat method here with the animal. So I'm just going to quickly do that, and I can say animal. Now the result of this will exactly be the same, but if I wanted to have, let's say, const other elements, so what I would do is I would say other animals, and here I can use the same code, which is the minimalistic code, and just have a negation here. So now we are checking if an animal is not a cat, then we basically log it. So I'm just going to copy this, and then we are going to see how this looks. So I'm going to put other elements here, and then if we run it, you can see that we have now got Choco and Brownie, which is a dog and a turtle, but not a cat. We have another example, and this is going to be a pretty interesting one because it involves maths, and if you are in programming, you love math or not, I'm not sure. But we have some transactions here, so I'm just going to comment or uncomment these out. So what we have here is that we have a bunch of transactions. So we have, let's say in US dollars, we have $50, we have 176, we have 224. Now every transaction could have a discount price. For instance, you are running a shop and you have a discount of, let's say, 20% for a particular use case. And then finally, we have the tax amount also being applied to every particular entry. So what we have to do here is that we have to calculate what is the total amount of transactions of these transactions array. So in order to do so, what we do here is that we loop over the transactions, and then what we do is we take the current transaction in the loop, and then we multiply the transaction with the discount percentage. So let's say if the discount percentage is 23, this means that we are providing a 23% discount. So we just multiply the discount percent, divide by 100 for the percentage reasons, of course, and then we add the VAT into the transaction. So we are modifying the transaction element every now and then. And finally, we have the total transactions, in which we start from 0, but then we finally add every transaction after every loop, and then we finally log those total transactions. So if I run this now, it's a pretty neat code. We have 148.5 as an output of this transactions array. Now, the interesting part here is, how do you test this code? Or what would happen if this code grows and you have a bunch of other things throwing in? So it basically becomes a lot messier to kind of work with this scenario, specifically if you are doing calculations like this. So what we could do instead is that we could have some functions that I'm going to throw up here to save time, and then we are going to talk about those functions and see how we could use them instead of this the situation that we have. So first of all, I'm going to comment these ones because these are external dependencies of the functions that we have, and then we have these functions. So let me tell you what I've done. We have an apply discount method which takes a value and then it applies the discount on top of that. So it's the same thing that we were doing here, but now within a function. Also, this discount percent is set within the function, so it does not depend upon any external dependency. So it's a pure function. Whenever you provide a value x, this will always produce a return value of y. Same for the VAT or the tax. So it takes a value, it has the value of tax, and then it combines all of those and sums it up and then returns a value. And then finally, for kind of calculating a total of all of these transactions, we have a sum function which will be used with a reduce function. So we'll see how this kind of compiles down to a really nice code that is easier to read and also easier to test. Now, all of this that I had to do can be done in one line, and I'm going to show you how. So I can simply say const, or I can just update this total transactions variable. So I can say total transactions equals, and then we are talking about transactions dot. First we map every item. So we get an item, and then we just use the apply discount method here. So what happens is that first we apply the discount. So you can see that we have this value here, and then it takes it, and then we apply the discount. Then we do another map. So we can simply say dot map, and I'm going to just expand this a bit so we have a clear view. And we have add VAT. So this is the second method that we have thrown to this code. And finally, we have reduce. So we reduce this with the sum method and we initiate it with the 0. So as you can see that reduce has basically the second argument as the initial value. So we are providing 0 here. Now that we have this, if I try to, let me fix this. So if I try to log total transactions now, it should still be the same value. So we are actually getting out the exact same result, but with a functional mindset, with a functional paradigm. So you can see that this is a lot cleaner. And what's amazing is that now you can actually test these functions. So you can write unit tests for apply discount, you can write unit tests for add VAT, and whenever something goes wrong or some logic changes, you will know that, okay, the calculations are not working. Why isn't it working? So you will know with the tests, okay, something is wrong and I have to fix that. So this is pretty interesting, and I'm really happy to share this with you. And I have something special towards the end for the senior developers, I would say, who might be thinking that, hey, I know these things, I have been working with JavaScript for like years and years, but there's something really interesting towards the end. So make sure that you watch this stream or this video till the end. So moving forward, we have now avoided mutation. Amazing job. The next thing I would like to say, which is for the senior engineers, is composing. So compose them functions. How do we compose functions and what is the benefit of it? If we take out this map, filter, reduce example, specifically the transaction example, what we could do is that we could actually compose these functions together to have an even better view. Tell me on the stream, within the comments how many of you have worked with RxJS or Lodash or any library that allows you to chain the functions. For instance, you could have something .flatmap, .map, schedule or .tab. So there are a lot of functions which we use and then we get some set of functions back from them. Similarly, we can chain different functions in a composed way. You might have seen in the Redux library that they have combined reducers. They also have some different methodologies which take different functions and then apply them one by one. So we are going to do this neat trick to combine those functions that we have already, and then we'll see how that works. So first of all, let me explain what we are doing here. What we are doing here is that we have a compose function, and the compose function basically takes a couple of functions, and then what it does is that it returns a function with the value x, and then we basically reduce on those functions, and then we basically apply the function one by one, and then we send back the response to the next function. So consider it like this. The first function takes the input, it processes something, and then it returns back the value. Then the second input takes the output of the first function, and then it goes on and on. So every next function gets the output of the previous function, and that's how we are composing things. So in the general sense of code, what we would usually do is that we could have const, we could have calculate total, and then we would do something like this if we were to use the callback scenario that we are used to. So we could do something like sum, and then we would have some kind of filter. So we would do transactions dot map, and then we would have something like apply discount, and then in this map then we will also do some more map. So it would be something like this, okay? But what we want to do is to be able to compose these functions and run them one by one. So what we could do is that we could create a function calculate total, and this calculate total will receive the transactions array. So it is supposed to get an array. So what we can do here is that we can say compose, and this is using this compose function now. So in compose, we can first create our own function, and I could have created this function above with a particular name, but I can actually do that. So what we can do is that we can say const process transaction, let's say, and then what we could do is we will get transactions. So what we would do is that we will say return transactions.map. Now this map will get some more composition, so I can simply say compose. So this is the second compose that we are using, and now in this one we can first say apply discount, and the second thing will be add VAT. So what we are doing here is that for each transaction we are mapping, and then we are using this composition, and we are saying, hey, apply discount first. So the transaction value will first come here, and then it will do its calculation, then it will return the value here into the VAT function. So we are kind of chaining these functions now. So once we have done this, the next step is to create another function. So we can say const, and we can say sum total, and what this will have is this will also get these transactions as an array. So what we will have is transactions, and then here what we would have is return transactions dot reduce, and here we have the sum and the 0. So this is what we are doing here. Now in order to kind of use this, what we will do is that we can simply say process transaction. Now what I'm going to do right now is I'm just going to say console.log, and I'll say calculate total, and then I'm going to provide a value here. I have to provide the transactions array. So transactions, and now we are providing this array here. So this array will basically go to calculate total, which in sense will go to process transaction, and here it will basically do all of the magic. So I'm going to put an S here since there are multiple transactions. Now if I try to run this, duplicate declaration calculate total, because I have the code here in case of emergencies. So now if I run this, you can see that we have these array elements. So what's happening so far? This calculate total is basically applying process transactions, which goes inside, applies the VAT and the discount to each element and then returns it back. So it's doing all of the things that we were doing before, nothing fancy, nothing magical, but still it's kind of doing this in a composed way. Now, the only thing remaining is to use the calculate total with this total sum. So just to do that, we can create and add the sum total method here. So the output of this process transactions, which is being returned from here, will become the input of this sum total. And then we just reduce over it, and then we use the sum method to kind of accumulate the results. And if I run now, boom, now we have 148.5, which is the same result as what we had here. So what we were doing here is exactly same as here, but now if you see the code, it's much cleaner to the eye. It's much easier to understand. It's much easier to test. And that is the idea of functional programming. And I hope that this neat trick would be appreciated by the senior engineers specifically. And if you like it, do share on the comments how you liked it. Having said that, we are actually towards the end, and that's pretty much it. So I would love to say thank you to everyone who has joined the stream, and I'm open to questions now. A quick note that I have changed my Twitter handle. This is now I am Ayaz, and also I have a Facebook page, which is also I am Ayaz, and the GitHub is Ayaz. So if you have not followed me yet on these channels, do it. And yeah, just be in touch, and you'll learn these cool things every now and then. And also I have a YouTube channel where I upload cool videos like this every now and then. So if you have not subscribed there as well, do it. I'm almost about 700 subscribers at the moment, and we are going towards 1,000. I would love your support on this one, and I'll be really happy for that. It's time that I introduce myself. So I'm Ayaz. I am a senior software engineer at Klarna. I have over 7 years of experience with JavaScript, both on front end and back end. I've been working with Ionic, Angular, React, React Native. I recently started working on Flutter, and I am a Google developers expert in Angular and web technologies. So if you have any concerns or questions with Angular or Ionic Angular or even Flutter, you can always reach me out.